Imagine you're just looking up at the night sky, right? You're admiring the glowing face of our moon, all while knowing there is a massive, building-sized rock hurtling through the dark void of space, locked on a direct collision course with it. Sounds crazy, but in early 2025, that terrifying scenario wasn't just some plot for a blockbuster sci-fi movie. It was a very real data point, and it had the entire global astronomical community on high alert. So welcome to this explainer. I'm your host, and today we're unpacking one of the absolute most thrilling cosmic detective stories of the decade. We're going to look at this terrifying initial threat, the cutting-edge tech that stepped in to save the day, and what this all actually means for the safety of our pale blue dot. So get ready, because the clock is ticking. Okay, let's dive into this. The whole saga really centers around a near-Earth object designated as Asteroid 2024 YR4. Now, shortly after its discovery, scientists who were calculating its trajectory started to notice something, well, highly concerning. The math was pointing toward a seriously alarming possibility, a potential intersection with the moon's orbit. And we're not talking about millions of years from now either. We're talking about the year 2032. So this whisper of a 2032 lunar collision started rippling through planetary defense networks. Because think about it. If a massive space rock were to strike the moon, it wouldn't just be some spectacular light show for us down here. It would be a violently destructive event. It could potentially send hazardous lunar debris outward into space and, permanently alter the face of our closest celestial neighbor. And then the numbers got incredibly specific and honestly incredibly scary. In early 2025, NASA and other global space agencies assessed the risk, and they actually assigned a hard number to this potential catastrophe: 3.1%. Now, in our everyday lives, a 3% chance of rain means you probably don't even bother packing an umbrella, right? But in the world of planetary defense and orbital mechanics, a 3.1% impact probability is massive. Like, it is a glaring, flashing red alert. Space is incredibly vast, so the chances of two objects hitting each other are usually calculated in the millionths of a percent. So this 3.1% figure, it effectively set a cosmic ticking clock, launching this urgent, high-stakes campaign to track 2024 YR4.
Which brings us to Section 4, the complication, a trail gone cold in deep space.
See, just when humanity desperately needed to keep its eyes completely glued to this incoming threat, the universe decided to throw a massive curveball our way. Tracking asteroids requires continuous observation to really refine those orbital models. But space is dynamic, it's chaotic, and things rarely just stay easy to see. Our ground-based telescopes, which are the traditional workhorses of our planetary defense network, they are incredible tools, absolutely, but they have their limits. As 2024 YR4 continued along its orbit, it drifted further and further away from Earth. It just became too distant, too small, and way too faint to be detected by the observatories we have stationed right here on the ground. The trail went entirely cold. I mean, think about that. We had a 3.1% chance of a lunar impact, a ticking clock pointing straight to 2032, and suddenly, we couldn't even see the asteroid anymore. We desperately needed a technological hero to step in from the void.
And that leads us right into Section 6. The cavalry arrives. JWST joins the cosmic hunt.
Because when ground-based optics fail, you call in the heavy artillery. Enter NASA's James Webb Space Telescope. Now, we normally think of Webb peering billions of light years away, right? Looking back to the very dawn of the universe, studying ancient galaxies, dormant black holes, the whole shebang. But Webb is also an extraordinary tool for studying our own local neighborhood. Because it operates in the infrared spectrum, it can actually detect the faint heat signatures of dark, cold rocks floating in deep space, stuff that optical telescopes completely miss. So, in April 2025, JWST was officially retasked as a cosmic detective, and it turned its massive golden mirrors toward the estimated location of 2024 YR4. And not only did it successfully spot the asteroid, but it confirmed its terrifying scale. Now, what's really interesting about this is the confirmation that Asteroid 2024 YR4 is building-sized. Grounding this in everyday terms just makes it so much more real, doesn't it? We aren't talking about some tiny pebble that would burn up innocuously in an atmosphere. No, we're talking about a literal skyscraper made of ancient space rubble traveling at tens of thousands of miles per hour. The stakes for that 2032 encounter had literally never been clearer.
Let's just take a step back and look at how rapidly this all escalated. We start out with the sheer panic of early 2025 with that massive 3.1% impact risk. Then that April 2025 Webb observation confirms, yep, we are dealing with the building-sized rock. But here's the thing, knowing its size isn't the same as knowing its exact path. To definitively predict exactly where 2024 YR4 would be in 2032, scientists needed a lot more data points to plot the trajectory. And this brings us to some absolutely critical dates: February 18th and February 26th of 2026. On these days, the James Webb Space Telescope locked onto the asteroid again, and it captured vital, high-precision positional data. This new data was immediately rushed over to NASA's planetary defense experts for the ultimate math test, leading us right up to March 5th, 2026.
Section 9, the final verdict, solving the 2032 mystery.
This was the exact moment the entire astronomical community had been waiting for. On March 5th, the experts at NASA finally completed their rigorous analysis of that fresh JWST data. The orbital models were refined with just unprecedented accuracy. The trajectory was totally locked in. The definitive conclusion? Zero chance. So the crucial point is, NASA officially eliminated any chance of a 2032 lunar impact by asteroid 2024 YR4. The math is absolute. The rock is going to fly by completely harmlessly. I mean, you can almost hear the collective sigh of relief from scientists and skywatchers all around the globe, right? Our moon is safe from this particular skyscraper of space rock. But while this specific threat has been neutralized, the entire event really served as a massive wake-up call for humanity.
Moving on to Section 11, our planetary defense network, protecting the pale blue dot.
You see, the 2024 YR4 scare was ultimately a fire drill, sure, but it was an incredibly necessary one. It proved that the cosmos is a busy, highly chaotic place with rocks and debris constantly zipping through our local space. But more importantly, it proved that we need to be watching, constantly. Enter the European Space Agency's FlyEye telescope, and this brilliantly illustrates how we're adapting. It's essentially an automated, bug-eyed asteroid hunter. Instead of having just one single narrow view of the sky like a traditional telescope, the FlyEye splits the image into multiple channels, literally just like the compound eye of a fly. This allows it to automatically scan massive, wide swaths of the sky every single night. It's designed specifically for the early detection of near-Earth objects. It's kind of like having a robotic sentry constantly patrolling the perimeter of our planet, just ensuring no random rock sneaks up on us unnoticed.
But if we really want to talk about the future of planetary defense, we have got to look at the NSF DOE Vera C. Rubin Observatory, which is located high up in the mountains of Chile. This facility is an absolute game changer. I mean it. It is a real-time discovery machine that takes about 1,000 images a night, covering the entire visible southern sky every 3 to 4 nights. By doing so, it's expected to find literally millions of previously unseen asteroids, comets, and even interstellar objects. This single observatory is going to completely revolutionize our catalog of space hazards, spotting potential Earth and Moon impactors long before they ever get close to that terrifying 3.1% probability threshold.
To really understand how unimaginably powerful the Rubin Observatory is, just consider this number: 2,104. During its initial observation period, in just a single 10-hour window, the Rubin Observatory discovered 2,104 never-before-seen asteroids right here in our solar system. Just to put that into perspective for you, all the other ground and space-based observatories combined discover about 20,000 asteroids annually. The Rubin Observatory found more than 10% of the global annual average in less than half a day. It's just wild. This staggering efficiency is exactly why this matters, because the more eyes we have on the sky, the safer our pale blue dot becomes.
Which brings us to our final thought for this explainer. The crisis of asteroid 2024 YR4 has officially passed. It's going to sail right on by our moon in 2032. But the solar system is vast, it's dynamic, and it is full of ancient rubble left over from the very dawn of creation. As our telescopes get better and stronger and faster, we're only going to see more of it. Asteroid 2024 YR4 will miss us, but when will the next building-sized rock appear on our radar? Will it be tomorrow, next month, 10 years from now? Well, thanks to incredible tools like the James Webb Space Telescope and the Vera C. Rubin Observatory, whenever that next rock does arrive in our sights, we are going to be ready to calculate the odds. Until then, keep looking up and stay curious.